New Bubble Jet printer technology aims for the ideal combination of digital photo printing capabilities, enhanced photo image quality, and high-speed printing performance. Precise, smooth and natural, realistic photo image quality. Smaller ink droplets with highly accurate placement are the key to this high level of image quality. Canon's new microfine droplet technology positions the heaters directly above the ink ejection opening, expelling the ink together with bubbles of air. Ultrafine, uniformly sized ink droplets are expelled at high speed with extremely accurate placement. The ink droplets form perfectly round dots, producing consistently high image quality. At Canon, printheads are manufactured using the world's first complete photolithography process. Integrating both heaters and nozzles, these printheads make possible the highly accurate ejection of ultrafine ink droplets. The combination of Canon's unique ejection method and our proprietary manufacturing process is what we call new microfine droplet technology. Now, Canon takes new microfine droplet technology to a new threshold with the introduction of even smaller ultrafine ink droplets. While retaining essential high-speed printing performance, Canon's advanced technology achieves ultra-realistic photo image quality with enhanced tonal gradation, particularly in the mid-range tones. Our new microfine droplet technology doesn't merely make the ink droplets smaller. Let's take a look at the advantages of new microfine droplet technology and how it compares to thermal inkjet and piezoelectric processes used by other manufacturers. Let's compare the printhead from a competitor's thermal inkjet printer. At a glance, the ejection method seems to be similar. But new microfine droplet technology boasts superior performance in several areas. The secret is in the manufacturing process. Other companies' manufacturing is based on an assembly process in which a film or a metal plate with ink ejection openings is bonded to a substrate. This process often results in manufacturing discrepancies. In addition, ink supply ports are formed by rotary cutter or by colliding microscopic particles at high speed. There is a limit to the accuracy of this machining process, and it is not possible to shorten the distance from the ink supply port to the ejection opening as in new microfine droplet technology. New microfine droplet technology employs semiconductor production technologies at every stage of the manufacturing process, creating an integrated unit that requires no assembly and greatly increasing the precision of the print nozzles. Canon's proprietary micromachining technology permits precise machining of the ink supply ports, making it possible to shorten the distance to the ejection opening. These short, precisely machined nozzles deliver significantly better ink ejection and printing quality performance. Because the distance from the heater to the ejection opening is longer, the ejection method used by competitors does not allow for complete ejection of the bubble, requiring repeated bubble generation and contraction processes. The position and timing of ink expulsion is inconsistent and easily affected by temperature variations and other factors. This results in the generation of ink droplets of varying sizes. And, as it is necessary to move volumes of ink in excess of the amount that is ejected, the combination of fluid resistance and the pullback effect lowers ejection force. The resulting ink droplets are subject to air resistance and may fail to strike the paper in precise alignment. With new microfine droplet technology, only a short distance separates the heater and the ejection opening, making it possible to cleanly eject all the ink. The effects of factors such as temperature variations are minimized, making it possible to eject a prescribed volume of ink with minimal irregularity. The ink is expelled forcefully, minimizing the effects of air resistance and ensuring precise placement of ink droplets. Now, let's take a look at the advantages of new microfine droplet technology compared to competing piezoelectric processes. First, let's examine the ejection process. These processes rely on deformation of an actuator, a piezoelectric element that pulls and pushes to eject the ink droplets. As these deformations are infinitesimal, a large element is needed to eject the required volume of ink from the nozzle. The resulting nozzle is long and large. Compared to new microfine droplet technology, the difference in size is significant. Because it is necessary to move a large amount of ink within the nozzle, changes in ink temperature and viscosity can easily affect the volume of the ink droplets. The force of ink ejection is weak, increasing the effects of air resistance and lowering the accuracy of drop placement. The sequence required to alter the piezoelectric element requires a more complex driving process for ink ejection, restricting head drive frequency. In comparison, the short nozzles employed by new microfine droplet technology permit high drive frequency. The difference in the number of ink droplets ejected in 1 second creates an effective advantage in printing speed. Like thermal inkjets, piezoelectric printheads are manufactured using an assembly method. For the piezoelectric process, fundamental limitations require assembly of multiple layers of parts. Precision is sacrificed, and shapes are inconsistent, with significant deviations between nozzles. And because the nozzles themselves are large and long, it is difficult to create high-density, multiple nozzle printheads. Dots laid down in a single pass of the printhead show low density and poor placement accuracy, affecting both print quality and print speed. The simple principle behind new microfine droplet technology permits utilization of semiconductor manufacturing processes for all steps, creating an integrated unit that requires no assembly, and significantly boosting the precision of the print nozzles. This structure and manufacturing method creates nozzles that are incomparably smaller than piezoelectric nozzles, making it easy to produce high-density multi-nozzle printheads. Because a single pass of the printhead produces high-density, highly accurate dot placement, new microfine droplet technology results in higher speed and higher quality printing compared to piezoelectric printers. Due to superior manufacturing and ink ejection methods, new microfine droplet technology produces significant advantages in accuracy, print quality, and speed, the most basic requirements for a printer.
Premium image quality, faithfully rendered. Let's look inside the core of a Bubble Jet printer. The printhead measures only about the size of a fingernail tip, yet it houses a total of 3,072 nozzles. And ink droplets ejected from the nozzle measure only 2 picoliters. That's about the same size as a particle of cosmetic powder. What's more, each nozzle in this printhead ejects microfine ink droplets at the high speed of 24,000 per second. This ultra-high performance printhead also ensures placement of ink droplets with ultra-high precision. We brought together our high-level materials and semiconductor production technologies to realize this ultra-high performance printhead. Original technologies from Canon continue to advance the image quality and output speed of Bubble Jet printers.